Oh, hello. You've just caught me checking the anaesthetic machine. Come on in. We're going to check a Datex Ohmeda today because it is a relatively simple machine and I can demonstrate to you the logic of checking a machine and following the gas from the wall to the delivery. The machines that we're using now are slightly more modern and check themselves. The reason I'm showing you this check is because it enables you to work out when the machine on its self-test tells you what's happening, you know why. So the machine is checked from the back. So the way I check the machine is to view it as a gas delivery device. It takes gas from the wall, it reduces the pressure, it takes it through to pick up some volatile anaesthetic agent, and then it delivers to the patient. So if you follow the gas, it's a relatively logical way to check the machine. Starting at the wall, we've got Schrader valves. So these are colour-coded and they have a collar which only fits with the one that it's colour-coded for. So white for oxygen, blue for nitrous, yellow for suction, and black for air. There's also a scavenging system here for waste gases. So generally speaking, you give them a tug test and they shouldn't be loose. The colours correspond to what's being delivered from behind the wall, but under very, very rare circumstances, someone from behind the wall during a maintenance could have swapped the pipes around. So although you're white to white, it might actually be delivering a different gas, so you still have to check it on the analyzer, which I'll show you later on the front. So we follow the pipes to the back of the machine. We now have something called a NIST, non-interchangeable screw thread. That's white to this cable, blue to there, and air to there. Again, these have unique threads which cannot be interchanged. At the back of the machine, we also have an oxygen cylinder, and we check that by turning on the valve and looking at the pressure gauges at the front. So I'm going to turn on the valve. Don't like that, that's leaking. So I'm going to take that off the manifold and have a look at it. The way you do that is you stick your foot under it to take the weight of the cylinder, undo the manifold clamp, flip it up, and drop it out of the hanger onto your foot. Be careful you do that because it's heavy. So we're missing a Bodox seal here. Someone has taken a Bodox seal over here and taken it off our yoke. This is a very ingenious bit of kit. It's a brass ring inside which is a rubber disc, and as the pressure from the cylinder increases, it expands and seals the gap. You can't use a cylinder without a Bodox seal. So these can sometimes go missing and the cylinder will not work. So I'm going to place that back on the pin. You'll also notice that we're labelled O2, and we have two pins here which are a pin index system, and they correspond with the two pins on the cylinder. So I'm going to fit the cylinder again with the Bodox seal on. So again, foot on the base of the cylinder, load the cylinder onto the pins, flip over the yoke and tighten it up, and then take the foot away and let it hang on the yoke. Now I'm going to turn the cylinder on again, and you can hear there is no leak. So I've turned the cylinder on and I'm going to just check now the pressure gauge to see that we actually have cylinder pressure. We do have cylinder pressure and it's about half full. So I'm going to turn it off now because I don't want the cylinder to confuse us when we're checking the rest of the gas from the pipeline. So the cylinder's off, the back has been checked, we're now going to go round to the front. Round to the front. And we're going to look at the operation of the machine to take the gas flow from the wall, reduce it in pressure and make it controllable. I'm going to turn the machine on. It's always very embarrassing if you can't find the switch to turn your anaesthetic machine on. So it's going to run a very short self-test now, and then it'll boot up the ventilator. Meantime, we've got these gas flows coming into the back, and they're now coming onto this rotameter block. The rotameter block is 3 glass tubes lined with anti-static coating with bobbins in them. And you can control these gas flows by rotating the rotameters at the base of the block. And you want to see that all of the rotameter bobbins go up to the top to make sure that the tube isn't cracked. You'll notice they're color-coded, and the oxygen rotameter is a scalloped octagon, so you can feel it in the dark. When you check whether the rotameters work, you need to see that the oxygen goes up to the top, and you need to see that when the nitrous goes on, the nitrous oxide, the oxygen goes up with it. That's a hypoxic guard. So you can see the nitrous going up, the oxygen goes with it to prevent a hypoxic mixture. If I turn the nitrous down, the oxygen stays up. If I have the nitrous back up again, and I turn the oxygen down, the nitrous will come down with it. And that is the other version of the hypoxic guard. And then we have air. So we can see that we've got a range of flows available, there's no cracks. That is selecting then a flow to go through our back bar to pick up volatile anaesthetic, which is from the vaporizer. We need to check that the vaporizer is seated correctly, that everything's tight. Oh, right, so that's loose, so that can cause a leak. So we need to make sure that's tight, and then you see that works and turns well. So that's fine. So what I'm going to do now is I'm going to check the integrity of the seals of the machine all the way through from the wall down to the rotameters, back bar, bypassing the circuit, which we'll check in a moment. So the way I do that is I place some flow, a couple of litres on all the systems through the rotameters, which opens up the valves. I then turn the machine off, the gas falls, although the rotameters are open, so the valves are open, but there's no gas flowing. I'm then going to take a negative pressure device, and I'm going to apply it to this valve here. So I'm going to open the auxiliary common gas outlet, the AGCO switch. That bypasses the circle breathing system and allows me to access the circuit here without anything to do with this. So the reason I'm doing that is to check if I've got a leak on the system. This is a negative pressure bulb, so if I include this end, squeeze out the air from the bulb stays compressed. Take my finger off, the bulb reinflates. So I'm going to do the same on the valve down here. And what I'm expecting is when I compress the bulb should stay compressed. So I know with the rotameters on and the vaporizer off, I've got no leaks. I'm now going to turn the vaporizer on. I've opened the valves there and it's reinflated, so I've got to squeeze it again. And what I'm expecting is that it should stay compressed. And it's jumped up immediately, it's not compressible. So I know, since I've turned on the vaporizer, I've got a leak somewhere. So that makes me think I need to look at the vaporizer. So we've checked the tightness. I'm going to take it off. So this is a pin system to prevent you putting two vaporizers on next to each other. The vaporizers sit on a back bar with O-ring seals. And I just noticed here there's an O-ring seal missing. Coincidentally, I've got an O-ring seal sat here on the top of the machine. I'm going to put that on. And I'm going to do the same procedure. So, bulb is compressed, turn on the anaesthetic machine, bulb reinflates, and now with the vaporizer on and the seal back on, the bulb stays compressed. So we've addressed a leak in the vaporizer. So we've checked from the wall to the back bar, the cylinder, the rotameters, the vaporizer. We've essentially checked all the way to the delivery system, which is now this part. So we know up to the valve, all of the machine is leak-free. What we need to do now is check whether our circuit, which is usually on most of our machines a circle system, has any leaks in it. So I'm going to turn the machine on again. And I'm just going to run a bit of oxygen through it. And what I'm going to look at is the integrity of the system. This is an adjustable pressure limiting valve. I'm going to close it down to its maximum. And I'm going to flush in some oxygen into the system using the oxygen flush. So this is a coaxial system with two limbs hidden in within one tube. And what I'm doing just to start with it is I'm just slightly occluding the tip and bouncing up and down on the bag, and I can see these flutter valves moving up and down. These sometimes get water on them and can stick, so I need to just see them jump up and down. Now I'm going to close the APL valve fully, and I'm going to see if I can maintain pressure in the system without it falling. So I've got my thumb over it, and actually I can't maintain a pressure. The pressure's not staying at 70, it's falling. So I've got a leak somewhere in this circle system. So what I've got to do is kind of look, listen and feel for leaks. So I'm putting pressure on again, and I can hear it leaking somewhere. It's not leaking from the bag, but I'm losing pressure. I can actually hear a leak somewhere in this housing. So this is one of the very hard to find leaks on this system. This is the oxygen electrode. It's frequently checked by ODPs, and sometimes it's not screwed back tight. And it's not screwed back tight in this case. So there's a leak. So I've tightened it up. It's hidden behind a panel, so if you don't know it's there, it's very hard to find. So I'm going to do the same thing again. I'm on 70 on the APL, and I'm pressing hard on the bag, and now I can generate 70 very easily. So I'm going to check the integrity of the system, and the way I'm going to do that is I'm going to fill up the system with an oxygen flush. I'm going to put the ventilator on, and I'm going to see the ventilator go up and down. So the bellows will go up and down on the ventilator. I'm then going to turn my flow right down. So I'm adding almost no gas into the circuit. What should happen is that the gas, this here bag should just inflate and deflate continuously like a human lung, with the gas going around and around and around. The bellows should just go up and down with no leak, even on low flows. So I do that for a minute just to see if anything is occurring. And it looks like we've got a fairly good seal on the system. If I accidentally introduce a leak into this system, you'll see the bellows fall. So imagine this balloon, this bag has a leak in it. You can see the bellows fall and you can hear a leak at the bag. And now the bellows are completely empty. So that would simulate a hole in this bag. So the way to look for holes in bags is to apply pressure to them and listen and feel, and you'll hear if there's a leak. you'll feel it on your face, and you can actually physically see it. One more safety feature on the bag that comes attached to the circuit. When you inflate it, if you inflate it quite a lot with your thumb over the end, you can look for imperfections in it, and it'll give you a clue as to whether there's a leak in it. This will keep inflating like this and generate the same pressure, so it's a safety feature. If you've accidentally left the APL valve locked down, it won't generate any more pressure on the patient. So I'm going to unlock the APL valve. So we've tested from the integrity of the wall, through the cylinders at the back, through the flow control rotameters, through the vaporizer, through the valve check, through the check of the circle system. So everything up to this point now has been checked. I'm going to put on a filter. Very occasionally debris can get inside this bit. So I'm now just checking as a final check that air comes out the front end. So I'll fill up the bag again with a flush and a fully locked down APL. I'm going to squeeze the bag and feel air coming out there. So I know there's nothing in that last piece that I've just added to the system. Now, as a final check, we want to check our CO2 analyzer works, and we want to check with a 3-point calibration that what's coming from the back of the wall is actually what it's labelled as. So, if I take the gas analyzer, which is plugged into the system, and I dial up 100% oxygen and put it into the tube, I should see the monitor change from a FiO2 of 22%, which is room air, 98%, so that's 100% oxygen coming through there. I'm now going to set it at 50-50 mixture with nitrous and oxygen, and that should give us a decalibration on the oxygen. So we've roughly got a 50-50 mix on the oxygen and the nitrous, which gives us a calibration that the oxygen analyzer is accurately reading 100%, 50% and 22% oxygen. So just to recap, the machine is designed to take high pressure gas from the pipeline, bring it through some limiters, enable you to control it with flows, add in volatile, and then put it through a circuit which you can hand ventilate or mechanically ventilate. So we've checked the integrity of the system all the way up to the circuit, and the circuit, we've checked that the gases we're delivering are the gases that they say they are. The only other things to remember, and in fact, if you're going to only remember one thing, forget all about everything else I've said. You want to make sure you've got a working suction and an ambi bag on the back of the machine. If you just have those things checked, that's great.